Welcome to your podcast for Lesson 32, Net Force in Two Dimensions. After watching the podcast, you should be able to examine normal force and observe different situations involving normal force and solve net force problems involving inclined planes. For class tomorrow, be able to describe a situation where the normal force acting on an object does not equal the weight of the object. Okay, if you remember what we learned in the last couple lessons, we know that normal force is a force that acts perpendicular to the surface that it's in contact with. And pretty much for every single problem that we've done, it's been an object sitting on a flat surface, and we know that the normal force is going to be perpendicular to that. We've also talked about weight, and we know that gravity is pulling this object downward, and we know that that's equal to Fw. And so far, we've learned that normal force and the force of weight are equal and opposite to each other. But this isn't always the case. So don't think that normal force is always going to be the opposite of weight. They're two different forces. And keep in mind that normal force is going to vary depending upon the situation of the object. For example, if we take this block that's sitting on a surface, and if we now tilt the surface and put that block on it, normal force is not going to be opposite of weight. Just to draw the forces on here quickly, we know again that weight is caused by gravity, and that always acts straight down. So even though this block is now on an inclined plane, Fw is acting straight down towards Earth's center. We also know our definition of normal force is a force that acts perpendicular to the contact surface. Okay? Here my contact surface is at a slant. This is going to be at a 90-degree angle or perpendicular to it. And so you can see in this particular example that our normal force is definitely not opposite of our weight. If you take a look at this problem, imagine that you are pushing a 1 kilogram book against a wall, and you are pushing with a force of 100 newtons. And so your applied force is going to be in this direction, and again that is 100 newtons. If we look at each of these situations, A, B, and C, we'll again see that normal force is not opposite of weight. Okay? And so I know that weight acts downward towards the center of Earth, so we have Fw, and we can do part A, finding the weight of the book, by using our equation that we learned last unit. So Fw equals mg, in this case a mass of 1 kilogram times g, is going to give us an Fw of 10 newtons. Part B, find the normal force acting on the book. Well, again, remember that normal force is always going to be perpendicular to the contact surface. And so I'm pushing this book against the wall, and my normal force is going to be perpendicular to that contact surface. Okay, so there's that right angle. Now, if we also bring in Newton's third law, we know that if my applied force of 100 newtons is being put against that book is therefore pushing on the wall. Newton's third law says the wall is pushing back with an equal and opposite force. So we know then that our normal force in this case is also equal to 100 newtons, because that book is not being pushed through the wall, nor is it being pushed back harder by the wall. Those forces are equal and opposite. Okay. Part C, find the force of friction acting on the book. Well, the key to understanding this part of the problem is remembering that the book is at rest. And so what that means is that my force of friction, we know always opposes motion. This isn't in motion, but if I would reduce my applied force on this book, if I reduce that 100 newtons, eventually we know that gravity is going to pull that book downwards. And so the force of friction is actually acting between that contact surface, okay, and that upwards direction. So we'll label that FF. And because we know that that book is at rest, I know that the force of friction has to be equal and opposite to my Fw, which in this case is 10 newtons. Okay, in this particular problem, we have a book, again, on the surface of a table, and we're pushing downward on the book with a force of 100 newtons. Okay, so there's our applied force of 100 newtons, and we know that this book is, again, having a mass of 1 kilogram. I know gravity is going to act on this book as well, and so we know that Fw is going to be equal to mg, or 1 times 10, which is 10 newtons. Okay? And again, we see the book is remaining at rest. Part A wants to know, what is the net force acting on the book? Well, if the book is not moving, if it's at rest, we know that net force equals 0. Okay. For part B then, the normal force, well, we know that the normal force is perpendicular to the contact surface, so we know it's going to be going in this direction. And in order for me to have a net force of 0, I know that that has to be equal to the force of my weight plus that applied force of me pushing down on it. And so 100 plus 10 gives me a normal force of 110 newtons. In this problem, we're now lifting upward on that book. So we are applying a force of 5 newtons in this direction. Okay. And the book still has a mass of 1 kilogram, so we know that it has an Fw, again, of 1 times 10, or 10 newtons. And again, we see that this book is at rest. So what is the net force acting on the book? Well, if it's at rest, again, we know that the net force has to be equal to 0. And if that's equal to 0, I know that my normal force is still going to be acting perpendicular to the contact surface. So there's my Fn. And I know that these forces in opposite directions have to be equal to each other. So in this case, my Fw is going to be equal to the sum of my applied force plus the net force. And so when I rearrange this, then I would take Fw minus Fa to give me my normal force. So 10 minus 5 is going to give me a normal force of 5 newtons as well. Okay, so I've got a total of 10 newtons in the upward direction and 10 newtons in the downward direction, again giving me that net force of 0. So we'll actually be doing this project in class tomorrow, but I want you to see if you can maybe think about this and draw a sketch of what's going to happen at home. We're going to place a cart on a track, and then we are going to take that track and tilt it up into the air at some angle so that it's inclined. So think about what we saw earlier in this podcast and see if you can draw the cart in the inclined plane and draw all the forces acting on the cart for class tomorrow.